Yeah. Good morning. We're going to see this example that you see on the screen, um, and we're going to analyze it using the block diagram method. So I'm going to write the steps on what we need to do, and then we're going to execute it as we go along. So let me disappear for here, and then we're going to go over here to the view the full page. So I am going to write down in here on the steps. Let's call it the steps. So the first step is going to be make a free body diagram. So make a free body diagram. We're gonna make a free body diagram, and then the second step that we are going to see is you could say lay out all the forces that act on the mass. So that's going to be the second step. So what we have in here, first of all, we have to recognize the elements that we have. As you can see, in here we have this, how do we do this? We have the force. This is the force. And then this is the mass in here. We have, of course, the spring. And then we have the damper, and we have this wall in here. So those are the elements that make up the system. So what I'm saying is we need to make a free body diagram first, and then we're going to do we're going to lay out the forces that act on the system. So let me do that. So here we have the mass. All right. And we need to lay out the forces that act on this. This would be our mass. Let's just use another color pen so that makes it nice to see. So we're gonna go over here. You're gonna say, okay, this is the force F. Yeah. And then you see, as I pull this to the right, let's say this is going to the right, what we are going to see is x dot and x, let's say, is to the right. And then in here to the left, we are going to see this force, which will be the value minus k times x. So if we do it to the right, we call this direction positive. If it is to the left, then it's going to be negative, you see. And so this is true too. We put another one that says v times x dot over here. So we have done what I'm suggesting that we do, that is to lay out the forces that act on the mass. That's exactly what we have done here. And then step number 3 is going to be, we need to apply Newton's law. So apply Newton's law that says the summation of forces equals to the rate of change of momentum. Yeah, that's what it is. Rate of change of momentum. Very good. So what I'll do is just go down here, and I said, okay, if this is true, I'm gonna say that F minus K times X minus B times X dot equals to the rate of change of momentum, meaning d dt of m times b, right? Mass times the velocity is the momentum. Change of momentum is rate of change of, so you could write this right hand side in many ways. You could say m times dv dt like this, yeah, and or you could write the right hand side of this m times x double dot, right? That's what dv dt is. So if this is true, we have actually done the second one in here, and then let's see here like this, yeah, very good. And then we're gonna say step number 4, we're gonna say I'm gonna translate the summation of forces into graphical representation. Okay, so what does that mean? It means that in here I am going to say that the application of Newton's law is basically the summation. You see what I'm saying is that in here it says the summation of forces. See, that's a key word, because what you are saying is that the summation of all these forces is equal to mass times dv dt, or mass times the acceleration like this. Okay, so now we are going to translate the summation of forces into some graphical representation. Let's do that. Now we'll say, okay, the graphical representation is, we'll say, okay, here. We're gonna use the circle for the summation. And this is the force F. This is one of the factors there. We're gonna say, okay, look, this is F. So it comes in here. And this obviously is a positive sign. Then it says minus bx dot and minus k times x. So why don't we write this minus b times x dot like that? And the other one would be minus k times x. Yeah. So what have we done? We have done f minus kx minus bx dot equals to mass times acceleration. So what we're going to do is we say, okay, we're going to put this like this, mass times acceleration like this. So you see what I have done is I have translated the mathematical representation that I had, and have translated the mathematical representation into a picture. So now we need to continue with our steps in here. Step number 5 is going to be I would say perform the integration or solution in graphical symbols. All right, what does it mean? Perform the integration graphical symbols. So from here, what we can say is, look, I am going to put this element in here as 1 over m, and I am going to do the integration in here, 1 over s, and this will produce x dot. See? Because this is going to be x double dot, and then if you produce another integration in here, this symbol of 1 over s is the Simulink integrator, x, yeah? And then in here we are going to complete the graph this way. So here we have this x dot. If you multiply this by the gain here that we say this is by b, you're going to have this term. And if you have this other one and you multiply by k here, you have the other term. See? And then we can put scope in here in such a way that you can actually see the answer. That's so that you can do a plot or look at the numbers. There's a way to put the scope in there. My point is that around the mass, here this is the mass. We saw the application of this for the see right here. This is the force, and then of course this is the spring force, and this is the damper force. We did a summation of the masses, and then we translated that summation into a picture, like you're seeing here. Yeah, you see this in here like this. It's the representation of this. So basically what has happened is this equation, this mathematical representation, is transformed into this block diagram. So this is the notation of this block diagram, which is now ready to go into Simulink. Yeah. So what we can do is we can translate this picture, or transfer I would say, this picture that we have developed, and once we have in Simulink, we can actually do the simulation to find out if you give it an input force, then obviously you could calculate what the output is going to be over here. See right here. So there we go. So let's do that right now. What I would suggest we do is we go and we bring the MATLAB up, and here we see our programs, and then you have MATLAB over here in here. Let's run that one. And what we are going to do is we are going to translate the that little picture into the block diagram form that we want. There we go. That's small enough so that we can manage it and that we can see it at the same time. You see on the background MATLAB is coming up. As soon as it comes up, what we need to do is to bring Simulink up so that we can actually transfer this picture into the Simulink. So that's what we're going to do next. As soon as MATLAB allows me, then we will run Simulink and transfer that picture, that graphical representation for doing the simulation. So we have to wait for a little bit until MATLAB comes up. This new version of MATLAB 2015, it looks like takes longer to load than the previous version. We'll see. Yeah, here we go. So what we're going to do is we say Simulink. Okay, do Simulink in here. And what it's going to do is going to bring up set of menus, and it will bring up the ability for us to create a new system completely. Let's see. I don't see yet the icons. We're gonna see it when it opens up. There is a set of icons that it says commonly used, and usually that's very helpful for what we're doing right now. I would say is sufficient. The only thing is that I don't see that is responding. Let's give it a try again. Hopefully there's no other hidden windows. There we go. So now Simulink has come up. See where it says commonly used blocks? I would suggest you do that, and also that you open the new modeling here. That gives us a window, yeah, right there, and so that we can build things. So what we need now, we need the model that is in OneNote, this one. So Let's see if we can leave it there and build it from the blocks that we have in here. All right. So the first thing we gotta do is to bring the blocks that we are going to need. We're gonna need this. I think, hold on for a second. We are going to need the summation one. We are going to need the integration one. Oh, we're gonna need these ones, like several of these. We need like 3 of these. So I'm just bringing up the ingredients that we have. We need one of those. We need the integrators. Where are those? They're right here. We need a couple of these. So what I'm saying is we need the elements that are in here. So these blocks. So what we're going to do is we're going to say, okay, look, this is the, we'll start with the summation point. In fact, I would, just to be on the organized side, I just put the ones that I needed. And in here, if I double click in here, it's going to bring up how many do I really want. And in here, I obviously want not too positive. We want one positive, and test of signs, this one, and then we have 2 minuses. So you see, there you go. So you put in here the way you do it, in case you don't remember, is you click on one and then you drag the mouse to the other one and it will make the connection. This one, instead of putting the value 1, I'll put the value F. Yeah. This one in here is going to be minus K, and this minus B times X dot. So in here we need this. All right. And in Simulink, if you click 1 and then you click the second block holding the shift key, it will actually connect this. Let me see. Let me try again. So we have this, and then we put the other one, and then you see, it creates the link. This one in here, I'm going to put it like 1 over m, like this. And then we have the 2 integrators. See right there? So you have this, and then we have the other one right here. Yeah. And then we have this one, which is the scope. And then you see you have this, you have 2 of these gains. See, we are completing this block diagram. If you do a control I, say control I, yeah, it inverts the things, which is what we really need. So this one in here is B. This other one that you see here is K. And then we will build this like this, see? So that's the B. The K times X, this is X in here. See, when you don't quite get it on the line, it won't join. Otherwise it does a fine job. But you see what happened now? I have translated this, I would say transferred this model that I had on CAN with a model that is in the computer program. So what would happen if I click on run here? If I click on run at this stage of the game, the computer is going to say, I don't really know those values. The ones that run the model. Um, perhaps, yeah, right here. See, there you go. The ones that run the model, what are the values of these physical parameters? The computer needs to know that. So one way to do it is to specify it at the prompt or to write it into a file. Because we only have 3 of those, I am going to do it right at the prompt, like f is going to be equals to 10. And then we're going to say that m is equal to 2. Then we're going to say that we have this stiffness in there. K is 1 over C. So this, now m we have m is equal to 2. What happened? Yeah, it is. We need K is equal to, let's see, 1 over 40. No, this is, K is like 30 or 40. Let's do 30, yeah. And then we have, we did B is equal to 3, let's say, just for the sake of example. And M we already have, and we enter K as well. So since we have the numbers, we should be able to do what we need to do here. I'm going to open this up, double click on the scope so that we will see the result. And then we go back over here and I just say, do it. And so if you click over here, the program is running. And in fact, it did run. We need to just auto scale this to see it. And then we see the response right away on the right hand side. My point in this whole situation is to outline these steps and follow them. Perhaps I'll make it a little bigger here. Let's see. Yeah, right here. These were the steps. Make a free body diagram where we put all the forces on the system. Lay out all the forces that act on the mass. Then apply Newton's law, do the summation of them. And then perform the integration. All right. So that's how we do it. We enter the physical parameters, and of course, on our block diagram here, enter the physical parameters, and we can get an answer. So that's the process of modeling and simulation using the block diagram method.